All right, this problem is, what is the molar solubility of cadmium 2 carbonate? This also comes from our practice for Module 7. Vocabulary from this module. The molar solubility is how much dissolves, which we know we can find from the ice table. We're essentially looking for X in the ice table, or at equilibrium, how much ion is there, how much dissolves into ion. We started learning this back in Module 4. Here's the K value at equilibrium, how much of each ion is there. So all that is new here is the vocabulary that we're introducing for these insoluble solids or slightly soluble solids. This requires that you write the formula for cadmium 2 carbonate. That's a Gen Chem 1 concept. We learned that in Gen Chem 1. We did review it at the beginning of the semester in that lab activity. But if you're still struggling with the nomenclature, Google nomenclature videos. I've got some on my website. Post a message on the discussion boards. Shoot me an email. I can send you some links to mine, because this is something that you need to be able to do. Now, you can Google cadmium 2 carbonate, but you do have to know enough to know if Google is telling you the right thing. Cadmium plus 2 ion is what this is talking about. And the carbonate ion, which is that, which means cadmium 2 carbonate has that formula. So I'm looking for the equilibrium constant for this in order to find the molar solubility. Now, the equilibrium constant is found in our KSP table, which is also a very good resource for your nomenclature. If I go to the KSP table, all right, I've already worked this one out before. If I go to the KSP table and go to the section of cadmium, there are my cadmium compounds that I have Ks for, KSP. This is my KSP table, my solubility product constants. So cadmium 2 carbonate looks like that, and his KSP is 5.2 times 10 to the minus 12. So KSP is 5.2 times 10 to the minus 12. So that is the equilibrium constant for that equilibrium reaction, which means it is the concentration of cadmium at equilibrium, the cadmium ion, and the concentration of the carbonate ion at equilibrium. Well, what are those at equilibrium? The left-hand column will always be M minus X, M minus X. Starting with 0 of each of these, I get plus X. So that's equal to X squared. So I can solve for X. X is my solubility, and I take 5.2 times 10 to the minus 12, and I take the square root of it to find X, and I get that 2.280 times 10 to the minus 6. So it looks like my answer is 2.3 times 10 to the minus 6. The stoichiometry here is 1-to-1, which is easier than when it's not, but it's still worked exactly the same way using the concepts we started learning back in Module 4.